This is the video for section 4.4 notes, slides 23 and 24. So continuing on with talking about the second derivative, let's read this. It says c comma f of c is an inflection point if and only if f of c is continuous at x equals c and f changes concavity at x equals c. All right, so what does it mean to change concavity? Well, if f double prime changes sign. Okay, now it's important to note that f prime and f double prime may or may not exist. So remember, f prime could be undefined, f double prime could be undefined, and as long as f is continuous, which means f is defined, then we can say that there is a point of inflection at c comma f of c. All right, so inflection point, that is the new thing. So now, if you remember back, okay, a couple slides ago, I said C was a special point, right, on slide 21. So the special point we now know is called an inflection point because that is where the concavity of the graph of f changes. All right, and so, all right, it says use the graphs below to determine the x value where f has a point of inflection. All right, so first of all, number one, this is a graph of f, but number two, this is a graph of f prime. So it's important that we pay attention to the difference. All right, so if I'm looking at this graph, I'm looking for the concavity of f. All right, so this graph is concave up until about -2, and then it changes to concave down. So there would be a point of inflection at x equals -2. So how do we know? Well, because this graph has a f double prime that is positive, and then over here, f double prime is negative. All right, so it is concave down until we get to 0.5, and then you can see that the curve changes, and now it is concave up. All right, because f double prime is positive. All right, then at about 2 here, the concavity changes. The curve changes from concave up to concave down. And so we would say at x equals -2, at x equals 0.5, and then at x equals +2 are points of inflection because that is where f double prime changes signs. Okay. Now, this is not a very AP-like question because you're looking at a graph of f and you're determining a concavity, right? You don't really have to know anything about calculus to do this. You just have to understand what a concave up or down curve looks like. All right, but now, number two, this is a graph of f prime. So now, here's what we need to think about. Okay, if I'm looking at this graph of f prime, what is f double prime on this graph? Well, remember, f double prime is the derivative of f prime. Therefore, it's the slope of f prime. So I want to think about, okay, what is the slope of this graph? Well, the slope of this graph is negative. Then at -3, it's 0. Then it's positive. Then at 1.5, it's 0. And then it's negative again. So the question is f double prime changing sign? So f double prime is negative there. Then f double prime is positive. Therefore, it changed signs at x equals -3. So at x equals -3 would be a point of inflection. Then f double prime is positive, and then over here, f double prime is negative. Therefore, it must have changed at 1.5. Okay, so remember, f double prime is the slope of the graph of f prime, right? It's the derivative of the graph of f prime. Okay, so it's important that we remember that when we say a point of inflection occurs when f double prime changes signs, okay, what else does that mean? That means that f prime changes sign of its slope. So the slope of f prime changes sign, okay? So if I look at this, the slope is negative, then the slope is positive. So point of inflection on f. Slope is positive, then slope is negative. All right. So in other words, we're saying, okay, that a point of inflection on f would occur when f prime has a local minimum or maximum. All right. So that is slide 23. All right. So let's move on to slide 24. All right, and that is talking about what we call the second derivative test for finding some, okay, important, some local extreme, not all. All right, so the second derivative test says if f prime of c equals 0, right? All three parts say that. If f prime of c equals 0 and f double prime of c is greater than 0, then f of c is a local minimum. If f prime of c equals 0 and f double prime of c is less than 0, then f of c is a local maximum. Or if f double prime of c equals 0 and if f prime of c equals 0 and f double prime of c equals 0, then the test is inconclusive. All right, so let's talk about what that means. If f prime of c is equal to 0 and f double prime of c is greater than 0. So what would that mean? Well, if the curve is concave up, right? Remember, that's what f double prime greater than 0 means. And at c, f prime is equal to 0, remember horizontal tangent, then you know that f of c is a local minimum, right? But if f double prime is negative, right, concave down, and f prime of c equals 0, right, horizontal tangent here, then it's a local maximum. All right, now, what about if f prime is equal to 0 and f double prime is equal to 0? Well, that means it's inconclusive. So now I need to give you a specific example to show you this. All right, let's say that f of x is x cubed, okay? So if f of x is x cubed, the graph would look like this, correct? All right, so what about f prime? F prime of x would be 3x squared, okay? Would you say that at x equals 0, f prime is 0? Well, yeah, f prime of 0 is 0, right? So we're talking about that point 0, 0. All right, but now what about f double prime? F double prime of x would be 6x. That is also 0 at 0, right? F double prime of 0 is 0, right? So what can we say about x equals 0? Well, the test is inconclusive, right? It is not, in this case, a local minimum or maximum, right? But what about f of x equals x to the fourth? All right, f of x equals x to the fourth. What does that graph look like? Well, it's kind of like a parabola. Looks like this. So what would you say is going on at x equals 0? Well, there's a local minimum there. But f prime of x would be 4x cubed. And wouldn't you say that f prime of 0 is 0? Yes, that's true. What about f double prime of x? That is 12x squared. But isn't f double prime of 0 also 0? So the fact that both of these things are true in both cases tells you that the test is inconclusive. It does not guarantee you a local minimum or maximum. All right, so now, generally speaking, if we're supposed to use the second derivative test, we would expect to get local mins and maxes, somewhere. All right, so this example says find the local extreme values using the second derivative test. All right, so that means what? Well, first of all, find f prime and set it equal to 0, right? So f prime of x would be 15x to the fourth minus 15x squared. So now remember, all of these start with f prime of c equals 0. So we want to set this equal to 0 and solve. So 15x to the fourth minus 15x squared, I can factor out a 15x squared, which leaves me with x squared minus 1. All right, so now I set 15x squared equal to 0, and I set x squared minus 1 equal to 0. All right, so then I divide by 15 square root, I get x equals 0. Here I add 1 square root, I get x equals plus or minus 1. All right, and so now we know that f prime of 0 is 0. We know that f prime of 1 is 0, and f prime of negative 1 is 0, right? And so, well, f prime of each of those is equal to 0. So now we need to figure out what f double prime is. All right, f double prime of x. All right, so 15x to the fourth minus 15x squared. All right, so what would 15x to the fourth, what would that derivative be? 4 times 15, so 60x cubed minus 30x, right? So now I want to determine whether or not f prime of 0 is positive, negative, or equal to 0. So f prime of 0, so that'd be 60 times 0 cubed minus 30 times 0, that's 0, okay? So we don't know if there's a min or max there. All right, but then f double prime, f double prime of 1, so that would be 60 times 1 cubed minus 30 times 1. All right, so 60 times 1 is 60, minus 30 is positive 30. which is greater than 0. So what does that tell you? Look up here. If f double prime c is greater than 0, then f of c is a local minimum, right? So that means that f, right? So f of 1 is a local minimum. All right, now f double prime of negative 1. 60 times negative 1 cubed minus 30 times negative 1. All right, 60 times negative 1 cubed is negative 1. So negative 60 minus 30 times negative 1, that would be plus 30. So that gives you negative 30, which is less than 0. So that tells you that f of negative 1 is well, remember, the second derivative was negative, right? So that puts us at number 2 here. So that tells you that f of negative 1 is a local maximum. Okay, now, going back, what about at 0? What would you say about f of 0? Well, you don't know, according to the second derivative test, whether it's a local min or max, and so then you'd have to revert to the first derivative test. You'd have to do a sign analysis to see if the derivative, the first derivative, changes signs, right, from negative to positive or positive to negative or something like that. Okay, the fact is, in this particular problem, f of 0 is neither a local min or max, okay, but it could be. The second derivative test just can't determine that. All right, so that is slide number 24.